Hello, welcome everyone. Uh, so we are back for our next session on algebra. So in the last session, we have already looked at some of the important questions and concepts in which we were making use of several algebraic, you can say, identities or rules. Now we'll extend that discussion further with another set of problems and concepts in which questions have been repeatedly seen to be coming in the exams. So let's get started with the sessions. So we'll first look at some of the questions which I brought. Then we'll look at few previous year questions as well, right? So please stay active with me. I'm going to respond to any of your queries as we go along, right? So please keep on sending me any of your queries and concerns as they come across. Okay. So here we start. Now, let's take this one as the question for the today. First one. Okay, so you can see x equals 3 minus square root of 8. And based on that, we have to find the value of this expression x raised to power 4 plus 1 over x raised to power 4. So it is very clear that actually inserting this value as such directly into this expression is a very tedious task, right? Taking the fourth power of this expression can be done. It's not deniable that we can't do it, but there must be a way out. So let's see what we should do. So first of all, this square root of 8 can be simplified as since 8 is 2 into 4. So we can obviously write x being 3 minus, so 4 becomes square root of 4 becomes 2. So this is 3 minus 2 root 2. Perfect. Now further to that, the thing is that looking at this expression, which is of the form a power of x plus a reciprocal of that. So a starting point here would be to find x plus 1 by x. And then we can try to reach to this power by squaring on both the sides. So that is a typical technique for such questions. So one thing you will find very helpful in this problem is that the way the x is given, if you take the reciprocal of it, it becomes a very easy value. So 1 over x, which is 1 over 3 minus 2 root 2. Now I hope all of us know how to rationalize an irrational expression, right? We need to rationalize this. So we need to multiply and divide by the conjugate of this, which means if this is 3 minus 2 root 2, then you multiply and divide by 3 plus 2 root 2. So that rationalizes the denominator, right? So this now becomes of the form a minus b into a plus b, which is a square minus b square. So in the denominator, what we have is now 3 square, which is 9, minus 2 root 2 square, which is nothing but 8. So that is 1. So effectively this is 1. So it means all I am left with is 3 plus 2 root 2 in the numerator. Perfect. So now the point is that 1 by x happens to become the conjugate of x. So now if I add x and 1 by x, so all I'm left with is an integer value, which is 3 plus 3, 6. 2 root 2 and minus 2 root 2 cancels. So now, as I was saying, that at this stage now, if we square on both the sides, we can reach to this value, right? So squaring both the sides. So using the basic a plus b whole square expansion on x plus 1 by x. So x plus 1 by x whole square will equal 6 square, which is 36. Now what will be x plus 1 by x whole square? X square plus 1 by x square plus 2 into x into 1 by x, which is 2, which is 36. So 2 goes over there. So this gives me x square plus 1 by x square is 36 minus 2, 34. So the way in which we easily could figure out x square plus 1 by x square from x plus 1 by x. Likewise, in the next step, we can now again do squaring on both the sides, repeat the process one more time, and that will help us to reach to the desired result. So x raised to power 4, squaring both the sides on this equation now, this whole square is this square. So x raised to power 4 plus 1 by x raised to power 4 plus 2, because 2 into this is 1. So 2 equals 34 square. 34 square is 1156. So our answer becomes x raised to power 4 plus 1 over x raised to power 4. That value is 1154. Right. All right. So this was how we should do. Could have done this one. Now, so let's see. Next one. Now, x equals 3 minus the square root of 8. Once again, we are given that value of x, but this time the value of the expression whose value has to be computed is not of the previous type. It is something else. It's a polynomial of fourth degree. Now, obviously, this question requires a different kind of approach, right? The previous approach was for that particular situation. Now, how do we deal with this? So let's understand. Now, so once again, our x is 3 minus 2 root 2. So if I have to find this expression, now we saw in the previous question that by simplifying this, by taking 1 by x, we got one result, which was x plus 1 by x is 6. So just say that we have reached to this result already. And now if we actually go on to further simplify this expression or this equation, in fact, then we'll have a quadratic equation in x, right? Which would be that x square plus 1 is 6x, or x square minus 6x plus 1 is 0. So this quadratic has two roots, one of which is 3 minus 2 root 2, which is the value for which we have to find the value of this expression. What I'm trying to say over here is that this quadratic equation, which I've just written, also has a root 3 plus 2 root 2. But remember, x is not 3 plus 2 root 2, but 3 minus 2 root 2. Now, if x square minus 6x plus 1 is 0, then how does that help me to say anything about the higher powers of x? I have to reach till there, isn't it? Okay. Now think about this. If this is 0, can I also say that if I multiply on both the sides with anything, any number, any variable, anything, it will still be 0? So let's say if I multiply this equation through by, let's say, x square. Why? Because I know I have to reach to x square. So is it wrong or is it okay to say that x raised to power 4 minus 6x cube plus x square is also 0? Now, do you see the connection or the logic that I'm trying to say over here? Which is that I can extract a higher, I can extract expression from the given target value, from which is 0 for the given value of x, and I can reach to a expression involving a lower power of x, right? So with this being the thought, let me start with this expression. Let me call this e, and let me say that in this expression I'm going to separate out terms which equal 0, one at a time. So first I'll separate out this exact expression. So I'm writing it like this: x square into x square minus 6x plus 1. So this would be exactly this expression, x4 minus 6x cube plus x square. But x4 is okay, but we have minus 6x cube here, whereas this had minus 5x cube. So can I say I need 1x cube to balance out? Minus 6 plus 1 is minus 5. So I'm balancing out the expression. Likewise, there is 1x square, but this was 2x square. So I need one more x square, and the 9x was already there. So now this is exactly what is written over here. I have written over here. And this, can I say, crosses. This is 0. So now I'm left with a cubic expression. So from fourth degree to third degree, from third degree to second degree, that is the idea. Keep on reducing the powers. Next, this is what I am left with. Again, let me say that this expression is, so multiplying this thing with x and sorry, this thing with x, and I'm writing over here, so x into x square minus 6x plus 1, right? So x cube is taken care of, there is 1 x square, but here there is minus 6x square, so I need a plus 7x square to balance out, right? So minus 6 plus 7 equals 1x square. There is 1x over here, but there were 9x, so I need 8x to balance out. So that is what we are now left with. This again becomes 0, right? X cube was there, minus 6 plus 7 plus x 1x square, x plus 8x 9x. Now I have this. Once again, I think this is the last step, I guess. So I'll write 7 into x square minus 6x plus 1 simply, right? So 7x square is taken care of. 8x is there, but this is minus 42x. So minus 42 plus 50 would be 8. So I need plus 50x. And a constant 7 has appeared here, but there was no constant term here. So I will need to write a minus 7. Right? Perfect. Now this is the last step. Now insert the value of x and then you have the answer. So this crosses. This is all I'm left with. So this equals 50 and 3 minus 2 root 2 and minus 7. So this is 150 minus 100 root 2 minus 7. So 150 minus 7, 143 minus 100 root 2. 100 root 2 is the same as 50 root 8. So option C. Perfect. So a different expression, polynomial for the, right? So a different approach was required, right? We wrote the quadratic which represented the given number and then used it in the given expression. And step by step kept on reducing the powers of the expression. So we have learned a new technique how to deal with this kind of problem. Okay. Now, next one. Let me see if you can tell me how we should proceed with this one, because we have our first problem was of this type. So uh, I'm extending that concept one step ahead with this problem. Now, you can see in this problem that it very clearly emphasizes that x is positive. If for x greater than 0, this equation is there, then what is the value of this? So, in the form of the expression, a power of 6 and plus a reciprocal of that. So, the sixth power value is given and the fifth power value is asked. So, this is not a very easy nut to crack, but with little algebraic, you can say tactics, it can be handled. How? Let's see. Okay. So the thing is, or the logic is that in all these questions, always remember the funda. X plus 1 by x is the path through which you have to go always, right? Means that is the starting point. Now, if you are given something in this form, x raised to power 6 kind of form, then your mindset should always be, okay, let me try to backtrack and trying to find the x plus 1 by x value. That can only help us to then further reach to x raised to power 5. So, with that being the mindset, right, and given that fact that we have understood in the first question that what is the expression of x plus 1 by x whole square, right? It was x square plus 1 by x square plus 2, right? So in that sense, this expression I would want to this given expression I would want to write it in the form of a perfect square. So let's do that. In order to do that, given that this identity over here, just add a 2 on both the sides, and then the LHS becomes a perfect square expression, right? X6 plus 1 by x6 plus 2 is as good as x cube plus 1 by x cube whole square, yes or no? Right? and that is therefore equal to 322 plus 2, 324, which is a very well known perfect square. It's a perfect square of 18. So we therefore get the value that x cube plus 1 by x cube is therefore plus or minus 18, technically speaking. That is the technical value. But given that x is positive from the problem, so we'll only write the positive number 18. So that is the step 1 of the backtracking. Now comes the challenging part. How to find x plus 1 by x from here. Again, I'll go back to the basics of identities, right? I'm using all the basic identities which all of us have done in 8th, 9th, 10th. All of us know the expression for a cube plus b cube. Let me write it over here. A cube plus b cube is a plus b whole cube minus 3ab a plus b. This is what we have, yes or no? Right. Now, so let's write this, give this expression in that form. So x cube plus 1 by x cube can be written therefore as x plus 1 by x whole cube minus 3 into x into 1 by x, which is 1. So 3, and then again in the bracket x plus 1 by x, right, which is equal to 18. Now, if you look at this expression carefully, then all that you have is x plus 1 by x, first the third power of that, and then that exactly. So if I just write x plus 1 by x as a variable t over here, can I say this is as good as I have written t cube minus 3t, which equals 18, right? So I'm just denoting x plus 1 by x over here as t. So now we have a cubic in t, cubic equation, you can say, isn't it? And I think we can do a little bit hit and trial over here, right, to try to figure out the value of t. So given that my RHS has 18, right, and if you look at this, so t should be a factor of 18 because we can factor out t from LHS in this equation. So we can try with factors of 18 like 2, 3, and so on. So if I put t equal to, let's say, 2, so 2 cube minus 3 into 2 is very small, it is just 8 minus 6, 2. But if I put t equal to 3, then 3 cube is 27, minus 3 into 3 is minus 9, and that exactly matches. So it means that our t is 3. So what we have got, x plus 1 by x is 3. So, to make the things, I mean, the question could have just given us x plus 1 by x is 3, and then we want to find this, then the question would have been easy. But it has given us a higher power, so we backtracked and we eventually came to this conclusion finally that x plus 1 by x is 3. Now, the question is just halfway through. We have to still find this expression of the fifth power. Now, if you have looked at my previous session, you might recall a similar question in which there was something to do with power 5, right? And I think that was x raised to power 5 plus y raised to power 5, which we had to find. And over there, I broke down the power of 5 as 2 plus 3, right? So I will take the similar approach over here as well, right? We already know that x cube plus 1 by x cube over here is 18 over here. That we already know, right? Now, from this, what we have got over here, let me then, I think we can easily find x square plus 1 by x square. And then we can combine both these results of x cube and then x square to find x power 5. So squaring this equation, which we had just got, can I say x square plus 1 by x square plus 2 is 9, which means that x square plus 1 by x square is coming to be 7. So now, as I said, let's club these two equations. So over here, I am multiplying them so that I'll get what I want, right? X square plus 1 by x square times x cube plus 1 by x cube. Multiplying these two equations, these results, this one and this one, is 18 into 7, which is 126, right? 18 into 7 is 126, perfect. So if we now carefully multiply these terms, we'll get what we want. We'll have x raised to power 5 plus, right, into this, and then multiplying the reciprocals 1 by x raised to power 5. But there are some extra terms also. X square into 1 by x cube will be 1 by x, and x cube into 1 by x square will be x. So there's an extra term coming as x plus 1 by x. So this plus this is 126, of which this thing is already we know 3, which we have obtained over here. So 126 minus 3, which is 123, is the required value of the given expression, right? 123. So I think this question is the summary of all the different varieties of problems that could ever be asked on this style of expression, right? X raised to power something plus a reciprocal of that. Perfect. Okay. Now let's look at the next one. Fourth question. Now, so now I'm entering the next concept that I have to bring to this session. Uh, the class of questions which I'm now going to discuss, a few of them, involve a very core concept on which questions have quite frequently been asked. And I have already used that in some of the previous questions, but this is a full scope of that, which is the very basic concept of completion of squares, which means you are given an expression like this. For example, you can see an equation over here involving three variables PQR. They are positive integers, they satisfy this relation. So you just have one equation involving three variables. Obviously, you cannot solve for anything at all. You just have this, and you are asked for the minimum possible value of the sum of the three variables. So whenever you see such a equation, a single equation, the first thought, right, related to it, that should be that try to express the given uh, equation in by completing the squares on them, recalling the fact that what is a plus b whole square, what is a minus b whole square, simple things like that. Okay. So see, let's see, what we need to do over here. So bring all the terms on one side, then you will be able to recognize how we should break this down. 4p square plus 25q square plus 9r square minus 12pq minus 24qr equals 0. Perfect. Now, a minus b whole square is a square minus 2ab plus b square, the most basic expansion. Therefore, now looking at this, these 12pq and 24q terms, they give you the idea what kind of expression will come in the perfect square. So 12pq is 2 into a into b. You can see 4p square over here, which is the square of 2p. So in the first term, if you write the first expression as 2p, then you will have 4p square. So your a over here is 2p. 2 into a into b is 12pq. A is 2p. 2 into 2p is 4p. 4p into 3q is 12pq. So what I'm trying to say, I should now write the second term over here as 3q. So that now on the expansion of this square, the terms will come as 4p square plus 9q square. So out of 25q square, 9q square is used, 16q square is remaining, which is another perfect square, which is the related to the next term which I'm going to write, and minus 12pq has also been used. So now what is left? Obviously, what is left is 16q square. So the next perfect square should start with 4q. And now looking at the fact that this is 24qr and you can see this is 9r square. So if you write 4q minus 3r, then the perfect square of that exactly matches with this 16q square. So 25q square, done. 9r square, done. Minus 2 into 4q into 3r, which is this term, is done. So eventually this expression turns out to be the sum of two perfect squares. So this equation now is of the form x square plus y square equals 0. No perfect square can ever take a negative value. So the only possible way to satisfy an equation of this form over here, x square plus y square is 0, the only thing that could happen is that both x and y, each of them need to be 0. So therefore, our inference can be drawn that this term is 0, which means 2p minus 3q is 0, or 2p is 3 equal to 3q, or p ratio q is 3 ratio 2 from here. Why am I writing the ratio of p and q? Because look at the question. He's asking for the minimum possible value of p plus q plus r. They are positive integers. So given the fact that they are integers, if 2p minus 3q is 0, so p should be a multiple of 3q should be a multiple of 2 is the inference. So the minimum possible values of p and q are 3 and 2 itself. But remember, there is not just p and q but r also. So the other term also needs to be 0. 4q therefore should be equal to 3r, or q ratio r is coming to be 3 ratio 4. So you see, at this stage, we need to merge the ratios, right? This is q is 2 over here, q is 3 over here. So we need to take the LCM of q over here and then find the merged ratio, right? Multiplying this ratio with 3, the first one, so that q becomes 6, 9 ratio 6, and here 3 is to 4, so 6 is to 8. 9 is to 6 is to 8 is the ratio, and these numbers 9, 6, 8 themselves, they represent the minimum possible value which PQ and R can take. Therefore, the answer is 9 plus 6, 15 plus 8, 23. Right? So looks magical at this stage if you are doing this or looking at this for the first time. But with practice, you will get the hang of this very important concept. And I'll try to bring relevant questions, more relevant questions of this type. Perfect. Ready for next one? Here we go. All right. So another problem on a similar style. You can again see there are three variables. There is a single equation about them, and the question is asking something. And obviously here we have to track from the options what could be the answer. We don't have to solve for anything as such. All right. Okay. So let's see how we should do this one. ABC satisfy this relation. 2a square 5b square plus 2c square is this. Now, so if I bring all the terms on LHS, I will have 2a square plus 5b square plus 2c square minus 2ab minus 6bc is 0. Perfect? Yeah. Now, uh, so now if I try to link this with completion of squares, this expression um, as such, the way it is written, it is a bit difficult to write it in this form. Why? I see 2ab over here. The only way I can complete a square using 2ab is a minus b whole square. But if I write a minus b whole square, then a square will still remain and 4b square will still remain. So how will I ever use that remaining a square? That cannot be used further, because then only the other term I'm having is only involving b and c. So seemingly this question is not that simple, or maybe it requires some smart work. So anything coming to your mind, let me know on this. What do you think we can do over here? Okay, so yeah, so this is a good question, I would say, and the manipulation required over here is this. You need to multiply this equation throughout with some factor. You see, I just said a while ago, If an equation is equal to 0, then multiplying throughout with anything, whether a constant or a variable, does not make a difference. The thing I said in the in the second question, in fact, right? So let's try to put a factor, I mean, multiply this equation with with a suitable number so that I can complete the square. You see, 2a square is right now not a perfect square. If I multiply this with 2, then 4a square will be a perfect square, and likewise 2c square will also become 4c square. So I will then be able to link it in that sense, right? So that manipulation is required, multiplying this equation with 2. So 4a square, 10b square, let's see how we can handle this, plus 4c square minus 4ab minus 12bc, right? Now, next step, now 4a square. So obviously I'll start the first term with 2a, and then this being minus 4ab, so I just need to write a minus b, so that I'll have a minus 4ab. So the whole square of this, 4a square completely used, minus 4ab used, out of the 10b square, 1b square used, 9b square remaining. 9b square is a perfect square. So the things seem to be going now the way it should go. So since now 9b square is remaining, so the second term should start with 3b, right? And since I see 12bc, so 2 into 3b, 6b into 2c. So I should write now 2c, and that is exactly what I have over here, 4c square. So now this is exactly what we did in the previous question also. The sum of two perfect squares is 0. But to reach to this required a little bit more effort. Now, in this question, remember the constraints are different. A, B, C are not integers, right? And we are not asked to find the minimum value. But we have to justify that which of the options is true. Nonetheless, whether A, B, C are integers or not, can I say that I can establish the ratio amongst A, B, and C in the similar manner? And then we can generalize the values of A, B, C, and then we can check with the options that what is true, right? So let's do that. At least that is what can be done. So quickly repeating that process, 2a equals b and 3b equals 2c. So a ratio b is 1 is to 2, right? A by b is 1 by 2, b is to c, b by c is 2 by 3, this is 2 is to 3. So the ratios are already linked up, b is 2 in both of them. So therefore the combined ratio of a is to b is to c is coming as 1 is to 2 is to 3, right? That's the ratio. Now using this, now we can check with the options. Means in general, can I say A is K, B is 2K, C is 3K for any real number K, right? K is not necessarily an integer, it can be any real number. Now, so now we have to quickly just check with the options that which uh, equation justifies these terms K, 2K, and 3K. So let's just check quickly. Option A says 2B, which is 2 into 2K, 4K, plus 5C, which is 5 into 3, 15K, 19K on the LHS. On the RHS, 3 into A, which is 3K, they are not matching. So option A is not correct. So in this way, I think we have to keep on going with the options. Option B, 3A, which is 3K, plus 2C, which is 2 into 3, 6K. Is it equal to 5B, which is 5 into 2, 10K? No. 9K not equal to 10K. Okay, so something will come, either C or D. Let's see, 5A, 5K plus 2B to 2 into 2K, 4K. Is it equal to 3C, which is 3 into 3, 9K? Yes. Finally, we have our answer, option C. Perfect. All right. Fine. I think this takes care of all the intricacies involving questions of completion of square concept, right? Okay. Now, some time for some previous year questions. Um, so this came in CAT 23. If x is a positive real number such that x raised to 8 plus 1 by x raised to power 8 is 47, then the value of x raised to 9 plus 1 by x raised to power 9 is. So I have in depth discussed the concept on this, and we have done a very similar question. So this is something that I think all of us should be able to do. All right, so let's discuss. Again, the central idea is finding the value of x plus 1 by x is always our motto, right? We should try to find that, and then anything can be done. So first we need to backtrack. We are given the x raised to power 8 value. So as we have seen, adding 2 on both the sides will do the completion of squares. So x raised to power 8 plus 1 upon that plus 2 is 47 plus 2 49. Yes, we can see we are getting a square number on the right hand side, 7 square. And this is the square of x raised to power 4 plus 1 by x raised to power 4. So that is 7 square. So we get the value that x raised to power 4 plus reciprocal is 7. Now don't say plus minus 7 because x is a positive real number. And in any which way, the x4 plus 1 by x4 value can never be negative. It's a fourth power number. It is always positive. In any which way, even if we get later on some value in which we can write plus minus, we know that we have to only take the positive value. Again, adding 2 on both the sides. Adding 2, x4 plus 1 by x4 plus 2, which is the square of x square plus 1 by x square, is turning out to be another perfect square, 7 plus 2, 9. So again, taking the square root, we get final one next step that x square plus 1 by x square is therefore 3, obviously. We still need to come back one more step. So again, adding 2 on both the sides. So x square plus 1 by x square plus 2, which is the whole square of x plus 1 by x, equals 3 plus 2, 5. Okay. So at last stage, we don't have a perfect square. We have 5. Nonetheless, we get that x plus 1 by x is technically speaking plus minus root 5, but we know that x is positive, so root 5. You can see all the options have root 5. So this makes sense now to us, right? Why root 5 is there? Because x plus 1 by x is root 5. So now we have to reach to the ninth power of x. So the way we have reached, for example, let's say to the eighth power is squaring of squaring of squaring. Likewise, the ninth power, right? We know that the cube of the cube is ninth power. So therefore, the obvious process now needs to be cubing the given equation on both the sides. So quickly doing this, x cube, right? The cube of this, x cube plus 1 by x cube plus 3 into x plus 1 by x once again equals the cube of root 5. Cube of root 5 means 5 power half whole power 3, because that is the meaning of square root of 5, 5 power half. So this is basically 5 power 3 by 2. So 3 by 2 means 1 plus half. So 5 power 1 means 5 into 5 power half means root 5. So I just explained in case anybody has any doubt. Root 5 whole cube means 5 root 5. I hope that is making sense to all of us. I have just explained to the very basic level why it is 5 root 5. Okay, so on the LHS, this term 3 into x plus 1 by x is 3 root 5. So when I take that on the right hand side, I get, because obviously I need to just simply write x cube plus 1 by x cube is how much? That is coming to be 2 root 5. 5 root 5 minus 3 root 5. Last step, cubing both sides once again will give us the answer. So cubing this equation, we get x9 plus 1 by x9 plus 3 into x cube plus 1 by x cube. Remember, we are cubing this equation over here, equals 2 root 5 whole cube, which is 2 cube 8 into root 5 whole cube, which is 5 root 5. So this is 40 root 5. And this term on the LHS is 3 into 2 root 5, 6 root 5. So our answer is 40 root 5 minus 6 root 5, which is 34 root 5. Right? So this came, as you can see, right, and required the similar approach. Okay, quickly, next one. Now, CAT 2018, this one. So the similar approach or manipulation is again required here. Again, you have a single equation involving two variables this time. So obviously you can't solve for u and v. Still, the point is you have to find a value of this expression. So you see, looking at this question, most of the people give up because they think that, oh, how can I ever solve for the unique values of u and v using a single equation? But the point is that again, if you do the completion of squares, then you get two results emerge from the single equation. When you see an equation on the form x square plus y square is 0, you get two results from that. That x should also be 0, y should also be 0. So sometimes a single equation does give you the unique value of the variables also. And that is exactly what will happen. Once you take the terms on the right hand side to the LHS, you will see that u square plus this comes over here. So this is 4uv plus 4v square. Now, you see already this term is written in the perfect square form. So half the job is already done for us. U minus 2v minus 1 whole square equals 0. We just have to now realize that this is nothing but u plus 2v whole square. So in a single line, you can see that it becomes easily, it can be seen as a sum of two perfect squares. So therefore, both of these should be 0, which is u plus 2v should be 0, as well as u minus 2v minus 1 should be 0, or u equals 2v plus 1. Just solve these simple equations first and second, and you can then answer the questions. So u equals 2v plus 1 from the second equation, which also equals minus 2v from the first equation. So we are getting this, that 4v plus 1 is 0, or v is minus 1 by 4. And if v is minus 1 by 4, then from here u, which is equal to minus 2v from the first equation, is half. U is half, v is minus 1 by 4. Therefore, u plus 3v is u, which is half, plus 3v, which is minus 3 by 4. So, half minus 3 by 4 is minus 1 by 4. Option A is the correct choice. Perfect. So, magic also happens in algebra. A single equation sometimes gives you the value of the variable because it could be an expression which is like the sum of two perfect squares. That's the idea. Okay. Cat 23 gave us exact repeated question. Cat also sometimes repeats questions. You see both of these questions. Cat 2018, this one. Next, Cat 23, this one. Exactly the same question. The only thing that they changed was what they asked. They asked for the value of x minus 2y. And this question is even simpler than the previous question. Why? Because we have already seen this equation is exactly of the same type. So it is turning out to be x plus 2y whole square once we take these terms on the LHS, plus x minus 2y minus 1 whole square is 0. And look at what they have asked. They asked the value of x minus 2y, and just our inference that this is 0 as well as this is 0. X plus 2y is 0, as well as x minus 2y minus 1 is 0, which means that x minus 2y minus 1 is 0, or x minus 2y is 1. Exactly that's what they are asking. They are asking for the value of x minus 2y, which is 1. So we don't even need to solve the equations, right? Perfect. So I hope this is building our confidence on, the basics of algebra involving identities, expressions, right? So in algebra, people I have seen, they mostly forget the core of algebra, which is identities and expressions. They directly start doing algebra with, okay, start the topic, quadratic, linear, um, um, sequence series, right? But the base level of algebra is what I'm doing for you, right? And questions have been asked on that. Okay, so take one last problem for today's session, which is this one. This is that question 2010, and what he's asking is the minimum value of a quadratic kind of an expression involving two variables x and y. you're going to see terms involving x square and y square are there, and we have to find the minimum value of this expression. Again, the core logic behind this problem is the same, which is that um, a perfect square is never negative. That's the core idea of any such questions. Once again, x is, you can say, let's say a square is greater than or equal to 0. That's the basic core idea of this problem. A perfect square is never negative. It is the minimum value of a perfect square could be 0, which happens when the term written inside the bracket is 0. So we would want to write this expression in that form. So let's work on this. Let's call this e equals this. So already it's written in this form where you can start doing the completion of squares. You see x square, you see minus 4y, you see 4xy, you see 4xy. So if you written x, then you need to write 2y, so that now that will the 4xy term will appear. So x square has been used, 4xy has been used. Out of the 6y square, 4y square has been used. So what is remaining is 2y square. So what we are left with is 2y square minus 4y plus 4. Now the next step is to focus on this remaining term, which is not written right now in the form of perfect square. So x plus 2y whole square, obviously we would want to make this term equal to 0, it the minimum value which it could take, plus we can factor out 2 from here, and then what will be left is in the bracket is y square minus 2y plus 2. Y square minus 2y will come from y minus 1 whole square. So this gives me y square minus 2y plus 1, but it was plus 2. So I'll write plus 1. Now I have done the completion of squares. So to minimize this expression, I would take y minus 1 whole square to be 0, which is means I would take y equal to 1, so that this term crosses off. And also I would want to make this term 0, which is its minimum possible value, which means x plus 2y is 0, or x equals minus 2y. Y already I have taken as 1, so x becomes minus 2. So when x is minus 2 and y is 1, this term crosses off, this term also crosses off, means this is it's 0, and all I'm left with is 2 into 1, 1, 2 into 1, 2, and that is the answer. Right. So you can also minimize an expression involving the concept of completion of squares. So this is what I had brought for today's session. Uh, so we'll soon meet for the next session that I'll plan on algebra. So please let me know how you found this session and what would you want me to incorporate in the future sessions on algebra. Your inputs are highly valuable. Please leave me your comments, your queries, and your expectations. What should be done, right? I'm planning my sessions keeping in mind all the things which are relevant, which are being asked. Next session tomorrow, 2nd June, same time, you can join us for an extended discussion on CDC 1 with all the experts, a full in-depth mock analysis. So I hope all of us you will come and join. So thank you so much, and see you in the next session.